Okay, this is section 3.5 in your textbook. We're looking at collecting like terms. They use a lot of these algebra tiles to represent different types of terms. I'm going to cover it very briefly. I don't think it's it's exceptionally useful. I think if you can pick up the algebra, you're much better off than using these algebra tiles, but we're going to go over it briefly. Okay, so to represent numbers, they use a very small square block algebra tile. Okay, and to represent the letters or the variables, they use a bigger block. And to represent variables squared, they use an even bigger block, which looks like, oh, we don't have any here. Here they are, okay? So when they have a square term, like this c squared term, they use these big square blocks. So these kind of L blocks, let's say, are represented by just the variable itself with an exponent of 1. If it's a squared variable, they'll use a square block, a big square block. And if it's just a constant or a number, they use this little tiny block. Okay? They also use the colors to represent whether it's negative or positive. So if it's a white block, they represent negative. If it's green, it's positive. Okay? So if we're looking at this example here, just using the algebra blocks, 5K, so there's 5 L blocks, 1, 2, 3, 4, 5, and that's because of the variable K, so we get that L block. There's negative 3K, so they represent it with the empty blocks, 1, 2, 3, and finally the constant 3, it's positive, so it's going to be green. There's 3 of them. Okay? Any questions about how these algebra blocks work? Okay, as I mentioned, I don't know it's totally useful. I think just going through some examples, you guys will have maybe an easier time with this. But I wanted to explain it in any event. Okay, so they're in quite a lot of examples. All right, so let's just go back here. So let's look at example 2. First of all, it's important to define like terms. So the definition is just terms that have identical variables. So like terms then are dictated by the letter or lack of letter. Okay, so in this case, it says identify the like terms in each group. So I'm going to look for the terms that have the same letter. Here, 2x, 5x, and 3x. So all of these would be considered like terms. Okay? The other two are not like, they're not like each other, and they're not like anything else. So this one and this one would be considered their own separate terms. Okay? So that's what we see here. 2x, 5x, and 3x all have the x variable. They are like terms. Okay? So we can if we were simplifying, we could add those up. If they were all positive, this would all translate to 2x, 5x is 7 plus 3x. This would all be equal to 10x. Okay? Any questions about that so far? First example? All right, Mark, the second example here. Can you name 2 like terms?
4a squared.
Yeah.
Negative a squared.
Very good. Okay. So these 2 are the only 2 here that are like. Okay. Everything else has a different exponent. Okay. The negative sign, that doesn't matter. That just means it's a negative value. When added to the 4, it's going to be 3a squared, right? When I add those 2 like terms together. Okay? 2a, there's nothing else like it. A cubed, there's nothing like it. And then a squared b, there's also nothing like that. All right, C. Luca, here. Second row. Like terms.
3u to the exponent of 2 and 2u to the exponent of 2.
Okay, good. Anything else that's like?
6 and negative 5.
Very good. Excuse me. So there's 2 sets of like terms there. So when we have like terms, we can combine them or, in other words, simplify them. So these 2 become 5u squared, and then these 2 become 1. Any questions there? All right. Pretty simple. So to simplify a polynomial expression, we add or subtract the like terms. All right, so we have 4x plus 3x. Guess what? We're going to have 7x. Okay, I'm not sure why you would need algebra tiles for that. You're adding 4 and 3 and an x. Okay, next we have 4x plus 3 plus 2x. So we're going to add the two like terms and add the other two like terms. So this is 8 and this is 6x. So we have 6x plus 8. Any questions on either of these examples? Okay, good. This is the basis for all the algebra you guys are going to do throughout high school, so it's very important we understand this. Next, we're subtracting 8x minus 3x. Sebastian?
It would be 11x.
No.
Oh, sorry, 5x.
Good. Hugo, 2x minus 5x.
Negative 3x.
Very good. Oh, we need a whole page for that. Okay, example 5. Collect like terms with concrete materials. So it says use algebra tiles to simplify each expression. So let's just do it without algebra tiles first of all. We can do that. Christian in the back.
Which question?
A, 5A, right up.
Okay. So it would be 5k minus 3k, which is equivalent to 2k.
Yeah,
And then it's negative 6 plus 3, which is equivalent to negative 3.
excellent.
So 5k minus 3.
2K minus 3.
2k.
Good. Joseph. So you got to look for what's like, okay, Joseph? So see how this is a square here and that's a square? So these two are the same. So what would they combine to give you?
That would be 7c squared.
No, careful, there's a negative sign here.
Oh, so it would be negative 1c squared.
Good, so negative c squared, we don't have to write the 1, good. Then what?
And then c plus negative 5c.
Yeah, c plus negative 5c or c minus 5c, so what's that?
So that would be
1 minus 5.
4c.
Negative 4c, right? Negative 4c. And finally, what are you left with?
2
Good. Minus or positive?
minus.
Good, yeah. Okay, so a little... You see how that works, Joseph? Yeah? So you're combining the like terms and simplifying, okay? You can go through the process of rewriting them so they're all next to each other, like they do, or you can just combine them, just keeping track of the sign that's in front of them, okay? Okay, see how they combine them first, they rewrite it, so they're all next to each other. You don't have to do that, but if it helps, you can. Okay, later on, you definitely won't be doing that. All right, example 6. AJ, A.
6?
Yep.
So is 6x plus 4. So you'd add.
What are the like terms, AJ? Tell me the like terms.
6x and 8x.
Good. So what's 6 plus 8?
14.
All right. So you have 14 what?
14x
Good.
plus 7.
Excellent. Easy, right?
Yeah.
Kyle in the back?
For 6b,
Yep.
2b minus b, so that would be just b
Yeah.
plus 7 minus 8.
Yeah. Yeah. Which is?
Negative 1.
Good. Okay. Sal.
So it's going to be
the 3r squared, you do minus, right? Like you subtract the 3r squared, right?
Yeah.
There's a minus there. So
Yeah.
So it's going to be just r squared.
No. 3 minus 3.
0.
Good.
So, oh, okay, yeah. So 1.
So they're gone. No, not 1, 0. They're gone.
Wait, okay. So then the r's are 15r.
No.
You don't add the 6r.
No.
Okay. 3r.
Okay.
And then plus 2.
Good. Okay, so do you see that? There was 2 like terms here. They actually cancel because we had 3r squared, and we're subtracting 3r squared. So that's 0. So I don't have to write 0r squared. I don't write that because it's 0. I might as well write 0h squared and 0b squared and all other random variables, right? I don't have to write that. So these go away. Now you're just combining -6 and 9. Careful with that negative sign, right? Sal missed it. He just added 6 and 9. You got to watch what's in front, okay? Max.
So you put the 0.5m and the other 0.5m together.
Okay, we can. We don't have to. We can, though. If you want, we can rewrite this if this helps, like this.
4.5n together, so you add those.
Okay, we can go through all that if you want. We don't have to, though. We can just look at the like terms, right? 0.5m and 0.7m. What is that?
That's 1.2.
Okay, good. So 1.2m. Then what?
And then you minus the 1.5 at the end. So you put that in.
Okay, what about the n?
Uh,
N as in new. There's a negative 0.5n and a positive 0.5.
well, since they're opposites, then they don't do anything.
Yeah, they actually, well, they cancel each other out. Good. And finally, what's on the end then?
The 1.5.
Okay. So when we collect like terms, we group or identify like terms. So it says group or identify. I prefer to identify because grouping, it's an extra step. You're rewriting everything. Just identify them. Look at them. Typically, you start with the highest degree term. Remember what a degree is? We learned this last time. You can tell me, what is a degree of a polynomial? Yeah, Henry?
It's like the sum of the exponents in the term.
Right, so it's the exponent. The highest exponent is the degree, okay? So typically, you start with the highest degree or the highest exponent term, okay? And then you just identify them. So find them in the equation, and then you add them. You add or subtract the like terms depending on whether it's a positive or negative. And then you apply the integer rules to the coefficient of like terms. So that's just adding or subtracting. And you do not change the variable parts. So in other words, you keep those like terms as they are, as they add or subtract. All right. So there's all our answers. All are correct. So finally, our key concepts. Like terms, they have identical variables. Again, the variable is another way of saying the letters, right? They have identical letters. Identical degree as well. You can simplify a polynomial by adding or subtracting like terms. This is called collecting like terms. Okay? It's helpful to think of only adding terms. When a subtraction sign appears, think of adding a negative term. I'm not sure if that helps you or not. For me, I think of subtracting when I see a negative sign, but if you want to think of adding a negative value, if that helps, you can do that too. Okay? Any questions about this lesson? It's pretty straightforward, pretty simple.
Sir?
Yep.
I still want to use the tiles.
Sorry?
The tiles, they're too confusing to me.
The tiles? Okay. Let's go offline. Well, let's stay online again. Okay, we'll explain it. Okay, let's look at this example. So the green tiles are positive numbers, okay, and the blank tiles are negative, all right? So when you have 5k, the longer tile or the L-shaped tile is represented by the variable, okay? When you have a variable squared, like this c squared, they do a bigger tile like this, okay? Because it's supposed to be like c and c. So c times c, this is c squared. Okay, do you get that?
Yeah.
All right. So if this is k here, these are k, so 5k, and we have negative 3k, they say these negative 3k cancel with the positive 3k. So these ones cancel these ones out. Right? So what you're left with is 2k here, and then these 3 tiles will fit into these 3 tiles. So they cancel those 3 out, and you're left with 3. So you're left with 2 and 3. Okay? 2k minus 3. Do you get it? Do we need the tiles? I don't think so. It's important to understand when you're doing the homework, so you can use the tiles if you need to, if there's a homework question that asks, but I won't typically put any tile questions on the test or quizzes, okay?
What are the big blocks again?
Therefore, when a term is raised to the power of 2, so like c squared, okay? Yep.
So what happens if, like, on both sides of the terms, the variables are the same, but they're not in the same order?
Like, give me an example.
Like for 2f.
151. F here. It says classify each pair of terms as either like or unlike. So we're just saying that these are unlike. So you were asking though, is this what you're asking? If it was this, like that, would they be like?
Yeah, no, I was just saying, because like the power is on the x and on the other one it's on the y, so it's asking, but it's the same variable.
Yeah, they're definitely not like. The powers have to be the same on the same variable. Okay? But they can be out of order like this. So these are both like. See this? You'll never see the textbook do something like this to you, though, to confuse you. They won't do that typically. But just so you know, this is still the same as this. They're both like, okay? But these ones are not, okay, because of this, that factor. All right? Any other questions?